new video in this playlist of oxidation and reduction. Hope you're all settling into school much easier now, and especially you fifth years. I hope you're okay with all the workload. So today we're going to be learning something very important called oxidation numbers. So if you remember my other video, we were talking about all the basics of oxidation reduction. So make sure you watch that one, otherwise you won't understand anything here. So oxidation numbers are so important. Without understanding them, you won't be able to do this important question called balancing redox equations. Balancing redox equations, you are literally stealing off the marks from the hands of the examiner because it's so straightforward if you know this important thing called oxidation numbers. Alright, so we said that word quite a lot. What is an oxidation number? Now, this may not be the textbook definition of an oxidation number, but I would say an oxidation number is the amount of electrons an atom will gain or lose to form a bond. So that will eventually become a compound or whatever it is. So it's the number of electrons that an atom is ready to gain or lose to bond with another element. Unfortunately, oxidation numbers are not the same as, let's say, it's not the same as, your atomic number. It's not that straightforward. So we have to follow a set of rules called, well, it doesn't have a name. I learned them from this YouTuber named Tyler Devesh. He's a great chemistry teacher. He helped me get through most of Leaving Cert, really, learning all the hard applications. So giving credit where credit is due. So these rules, you won't understand them by first glance, but I need to show you examples. I would say this is one of the topics where your knowledge of periodic table gets really tested. So I have my periodic table here. So any element by itself, that is anything from this periodic table, without anything joined to it, without anything bonded to it, is always 0 in its atomic number. Alright, so that's very straightforward. Na would be 0. O3 would be still 0. I know many of you will be like, there's 3, but as long as it's just a standalone, it is 0. Okay, same for magnesium, 0, zinc would be 0, and so on. As long as it's just standalone, it shouldn't be a compound. Just like that, anything from your group 1, so group 1s are over here, that would be +1. So hydrogen is +1, lithium is +1, Na is +1, but not by itself. So that would be NaCl. Na would be +1 here. I'll talk about the Cl later. So whenever you see a compound, let's say lithium sulfide, if I'm right, this would be +1. Sulfur, I'll talk about that later. Okay, so that's how it works. Alright, so group 2, same story, except this time it's going to be +2. So magnesium, let's say fluoride, magnesium fluoride, this would be +2, and I'll talk about this later. Okay, so that's how oxidation numbers work for those two groups. Now halogens. Halogens is just a fancy number, or the name, for group 7. It has 7 letters, that's how you remember group 7. So that's this one over here. That's -1 for most of them, except if it's bonded with oxygen, it's going to be +1. Don't worry about that too much, just keep that in your mind. So NaCl, going back to that example, Na, we know it's +1, and Cl would be -1. And if you look carefully, this both add up to 0. So one of the main rules of oxidation and reduction is that your oxidation numbers should add up to 0. It should total to 0. You understand that more after a few more examples. Alright, so next up is monoatomic ions. So mono means 1, atomic, atoms, and ions are any atoms with a particular charge. Now, if you watched my last video, you'll know ions became ions because they gained or lost their electrons. So let's say Zn +3, zinc +3. This basically means zinc lost 3 electrons. So your oxidation number straightforward, is plus 3. Because remember, the definition was basically the amount of electrons that an atom lost or gained to form a bond. So if you look at that definition correctly, you'll know that zinc lost 3, and therefore the oxidation number is plus 3. If you're confused about why it's plus 3 and not minus 3 when it's lost something, do watch that other video carefully and you'll understand. Okay, hydrogen. Hydrogen, lovely one. It's always plus 1. Alright, oxygen. That's why I don't use oxygen that much as an example. It is a weird one sometimes. So oxygen by itself is always minus 2, except in peroxides. So peroxides are these combinations like H2O2. That is hydrogen peroxides. Okay, so hydrogen peroxide catalyst, you'll learn that in the future. So manganese dioxide is the catalyst, not so on, for breaking down these things. That's for another video. But for this one, if I say it's minus 2, which it's not for oxygen, and we know it's plus 1 for one hydrogen. But look, there's 2 hydrogens here, so I'll have to count that as well. So that's going to be originally plus 2. And there's 2 oxygens, so that's going to be minus 4, because minus 2 multiplied by 2 is minus 4. That does not add up to 0. Your goal, remember, is to get to 0. So that's why there is a rule that in peroxides, oxygen is always going to be minus 1. Okay, so that will make sense. 2 oxygens would be minus 2, plus 2 minus 2 will equal 0. Alright, so I hope that makes sense a bit better. Alright, so the next up is fluorine. Okay, I don't know where my... Okay, sorry, this is all new settings. Excuse me for a moment. Okay, so got the tech back in control. Fluorine is always minus 1. It's always minus 1. It's extremely emphasized that it's always. Now you might be wondering why? Why is it always minus 1? Well, it has to do with electronegativity. Now you must have done that chapter before you get to oxidation and reduction. Negativity. Gosh, spelling. Electronegativity. So what is electronegativity? You'll find that in page 81, if I remember correctly, in your formula and tables. Please don't get confused between the normal periodic table and the electronegativity one. That would be a very painful one to deal with after the exam. So, electronegativity is the relative attraction between 2 atoms in a covalent bond for a shared pair of electrons. Said that out of my top of my head from all the learning off that I had to do. So, what it basically means in a nutshell, without all the chemistry English fanciness, is that it's the willingness of an atom to form a bond. Some atoms are like, nope, I don't really want to join with you, I don't want to mingle with you to form a compound. They're not great friends, I suppose. But if you look at this, fluorine, if you go check your page 81 of your formula and tables book, you will see this one has the highest number. If I remember, I think it has an electronegativity of 4. It is the most electronegative atom out of all of the elements in the periodic table. Okay, so this thing is just dying to go and get bonded with all of the other atoms to form compounds. So it's only fair that this will get a minus 1. So you understand that if you do more examples, which, talk about that, I'm going to let you do now. So there are a few examples here. CaBr2, KMnO4, ZNO3. Try that yourself, and then I'll do all of those with you right now in a moment. Okay, hope you got those done. Alright, let's get started. Ca, we know it's calcium, and that's group 2, so that's going to be plus 2. Br2 is from group 7, the halogens, but remember, we're only going to be talking about one atom. It's not the double atoms, it's just one atom. So Br by itself is going to be minus 1. But remember, plus 1 and minus 1, that doesn't make 0. But remember, there's 2 bromines, so you have to think about that as well. So in reality, it's going to be minus 2. Even though the oxidation number of Br by itself is minus 1, in this compound, To balance everything, it's minus 2, okay? So that would add up to 0. Plus 2 minus 2 is 0. Next one, extremely important. You'll see this quite a lot in exams. KMNO4, your best friend, potassium permanganate, alright? So potassium permanganate, we know the purple compound used for titrations, talking about that, I'll come back to those soon. So potassium is in group 1, so that's plus 1. We know oxygen is always minus 2, but look, there's 4 oxygens here, so I have to account for that. Minus 2 multiplied by 4 is minus 8. Okay, so plus 1 minus 8, these should add up to 0. So out of pure logic, you would know this is plus, excuse me. Wow, very logical of me to write that. Plus 7, okay? Because plus 1 plus 7 is plus 8 minus 8 is equal to 0. If you can't do those, you can just use basic algebra and then you'll get that, okay? That's how you do the small algebra bit. It's very helpful to do algebra instead of thinking in your mind. I know you might be like, that's such simple maths, but in the exam pressure, you'll do some stupid mistakes. So it's just best to do the things that you know that will work. Now, I'm just assuming algebra works out. So there's that. All right, so the next one is ZnO3. Okay, so we're going to do O3 first, because remember, Zn is a transition element. It's not standalone, so you can't say its oxidation number is 0, because it's not standing alone like Zn. It is bonded with oxygen. So this is ZnO3. So you do the ones that you know first. That's the rule. You do the ones that you know first. Okay, so oxygen is minus 2, but there's 3 oxygens here. So minus 2 multiplied by 3 is going to be 3 2s are 6 minus 6. Okay, so naturally, if this is minus 6, this has to be plus 6. So this would add up to 0. Okay, there's a bit of logic and common sense in this as well. So think before you do anything. Okay, let's say if this thing was Zn2, all right? I'm just giving you a hypothesis, all right? Let's say if this thing was Zn2, then what would you do? Okay, so we know it should be 6, but there's 2 Zn's. It's not just one. So what do? 6 divided by 2, 3. So the oxidation number of Zn here would be plus 3. If the question asks you what is the oxidation number of Zn, you will not say plus 6, you will say plus 3. Very tricky. The exam people are very huge in the tricksters, but don't fall for that because you know chemistry better. Okay. Next up, NaF. The star of last video, NaF. We know Na is plus 1 because it's in group 1. And as I said, always, 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 fluorine is minus 1. So that would be 0. Very easy. So that's how you do oxidation numbers as a whole. Alright, so you might be wondering, why did I watch this whole 10-minute video of oxidation numbers and so on? What's the point? Again, my system is acting up. Oh, gosh. Okay, hold on for a minute. Alright, sorry, excuse me. So, oxidation numbers, why did you ever watch this video? Well, you just gained yourself a good bit of marks, more than 12 marks in a question if this shows up in your question 4, and a huge jackpot of marks if this comes up as a question for balancing redox equations, because that would be the next video. Stay tuned for that. If you've enjoyed this video, found this helpful in any shape or form, please like it, subscribe to this channel, and share it so many people will get help, just like you did now. Alright, thank you so much for watching. You guys will improve, you guys will get better in whatever you're doing, and there's a great future waiting for you ahead. God bless you all, and I'll see you in the next video for balancing equations. See ya. Bye.